So in this module, we are going to be looking at the diesel engine generator. We are going to look at the two major parts of the diesel engine generator and then the various components that constitute these two major parts, their function, what they do within the equipment, and how each of these components interacts with one another to produce the overall function of the diesel engine generator, which is to convert the chemical energy that is contained in fuel into electrical energy that we will need in our facility. So without wasting much of our time, let us dive into the module proper. So like we said earlier, we have two major component parts to the diesel engine generator. So the first part is the mechanical part, or the diesel engine itself. That is what you are seeing here on your screen. So the function of this part of the generator is to convert the chemical energy that is contained in the fuel that is sent into it into rotating mechanical energy that will be available at this flywheel. That is the function of the diesel engine, and that is what you have here too. Here to here, this is the mechanical part or the diesel engine part. Then the second part of the generator is the electrical part, which is the generator itself, or in some cases referred to as the alternator. So this part of the equipment is the part that converts the rotating mechanical energy that is available here into electrical energy that will be sent into our facility for our use. So we are going to dive a little bit deeper into these two major components or parts of the generator. We are going to look at the various components that makes up the diesel engine, and then the various components that makes up the generator itself, or the electrical part of the generator, and what they do in the equipment. So this is the electrical part as we discussed earlier. This will now be coupled to the plate, the flywheel plate on the rotor of the alternator itself. Okay, that will be coupled to this flywheel for us to have this complete equipment. So let us look at the mechanical parts now, which is the engine itself. What are the constituent parts of the engine and what they do? So the first that we'll be looking at, like we said earlier, they are the components that makes up a diesel engine. Okay, and we are going to look at their operations, their function within the diesel engine as we go along. Then we're also going to look at the combustion process in the diesel engine, because that is the process that generates the rotating mechanical energy that we needed from the diesel engine. Then we'll look at briefly the types of diesel engine, the line and the V, and maybe the radar, though we are going to just show us the inline, okay, or the straight engine, and then the V engine of the diesel engine. And we'll look at the cooling system of the diesel engine. So let's take the first part down. The first part, okay, we're also going to be looking at the lubrication system of the diesel engine, and then the fuel system, okay, of the diesel engine. We are going to look at the intake and exhaust system, where we have the turbochargers. So this is the turbocharger. We'll also look at that briefly. So let us look at the first of the component parts of the diesel engine. Okay, so we are going to look at the component parts. So the first that we are going to be looking at is the engine block. The engine block of the diesel engine, that is what you are seeing here now. This is the engine block of the diesel engine. So the major function of the cylinder block or engine block, okay, is to house every other component of the diesel engine, okay, and to keep them in such position as to aid their functioning in providing that rotating mechanical energy that we needed from the diesel engine. So it is the carrier of every other component in the machine. That is what the engine block does, simply put. So this is the underside of the block, the engine block or the cylinder block. So you see the various journals on which the crankshaft sits in the diesel engine, and then as we'll see later, they have caps that will now hold the crankshaft into position, okay, or rather onto position. So as we said, it is the part that carries every other component of the diesel engine. It houses every other component, as we'll see later. So the next that we'll be looking at is the piston, okay. So this is the piston. If you look at the engine block that we saw earlier, you see that they have bores into which we have the cylinder, okay. So these bores actually accommodates the cylinders of the engine, and each of those pistons, they are designed such that they move along those cylinders. So its function basically is to receive the energy, okay, that is contained in the combustion product after combustion in the cylinder, in each of the cylinder. So it is the one that it is the piston that receives the entire energy, okay, or that is the energy that will be transferred down to the crankshaft, as we'll see later. So it is what will receive it, and then it will now transmit that energy to the connecting rod, okay. So it is actually this connecting rod that is connecting the piston to the crankshaft, okay. So as the piston is moving down, converts the energy that they receive from the combustion product in the cylinder into translational motion, okay. So that translational motion will now be sent to the crankshaft, as you can see here. So the crankshaft, its work basically is to convert this to and fro movement that will eventually result from the movement of the piston and the connecting rod into rotating mechanical energy, which we actually want from the shaft itself, okay. So the function of the crankshaft is to transform the translational motion or the to and fro motion or reciprocating motion, okay, of the piston and the connecting rod into rotating mechanical energy. So that is the function of the crankshaft, and this is what you are seeing here now. You see all of these journals, okay, they have the main journal, okay. These main journals, they are the ones that will sit on the the cylinder block itself, okay. Then this connecting rod, you see it is tied to all of these journals. Are we getting it? So which means that at these journals there are movements, and we have the metal contact at those journals, at those points of movement, okay. So because the rotational motion is always on those journals, so as they are moving like that, we need something that will aid such movement within the journal, and that is what the journal bearing does. You can see what we have here. These are the journal bearings. That is to enhance the movement around those journal and to reduce the metal to metal contact, to reduce the friction at those journals. So that is what we are seeing here. So these are the journal bearings. Okay, so if you look, we also have truss bearings. This is actually the journal bearings will take care of the rotational motion, while the truss bearing will take care of the to and fro motion of the crankshaft within the crankcase. Then if you look at the crankshaft very well, you see that we have hose. Okay, all of these, they are lubrication hose that we need to really take off while installing those journal bearings, so that the lubricant can get to those points or those journals to lubricate the journal, to ease the to ease the movement of either the connecting rod, okay, or of the crankshaft itself on the crankcase, that is around the main journal. So this is what you are seeing here. Then we have the jazz at the front of the journal. Okay, so the crankshaft, as we said, is the one that provides converts the to and fro movement or the reciprocating movement of the piston and connecting rod, okay, into rotating mechanical energy that will be made available. This is where the flywheel will be attached to. Okay, so the next part that we are going to be looking at, we have seen the cylinder block, the house. The piston is the part that receives the energy from the combustion product, that is converts the kinetic energy that is contained in the combustion product into the translational motion. Okay, then we have the connecting rod, and the connecting rod is connecting that piston to the crankshaft, so it helps to convert, that is to transfer that motion to the crankshaft, and then the crankshaft will convert that to and fro motion of the piston connecting rod combination into rotating mechanical energy. So we are going to be looking at the cylinder head now. The cylinder head, as the name implies, is what actually caps or covers the cylinder. So on it, in the diesel engine, you will see that we have some other components like the valves. Okay, that is the part that is housing the valve. Are we getting it? So we have both the inlet and the exhaust valve in them. We'll see their function later. Then it also carries the injector nozzle, okay, because that is what will now inject the fuel into the cylinder when the piston has gotten to the top dead center. Then also too, you see that it carries the induction manifold. That is the part that brings in the air, the combustion air, the air for combustion into the cylinder, and then it also carries the exhaust manifold. That is, after doing the work that it needs to do, the combustion product now pushing the piston down, it has to be exhausted. So it is exhausted through this exhaust manifold. So the cylinder head carries all of that. Okay, then covering it on the top, we have the valve cover. We also have the rocker arms, and then there are provisions for the push rod also to get to those rocker arms, okay, that aids the movement of the valves, okay, that is aids the opening and closing in consonance with the engine rotation, okay, so that we will not have misfire or problems during normal operation. So these are the rocker arms that we are talking about, okay, and these are the valves. So these valves, they are open at different times. Okay, if this is for a particular of this, if this is for this particular cylinder now, for a particular cylinder, if this is the intake and this is the discharge, you see that both of them will open up at different times, okay, because it is timed with the engine rotation. So we've looked at the cylinder head now. The next that we'll be looking at is the valve itself. Okay, remember we said we have the intake and the discharge. So what they do basically, as the name implies, is just a valve. It allows the intake of air into the combustion chamber, and then it also allows the discharge of used combustion products, okay, from the combustion chamber. So these are the valves, and that is exactly what they do. Then we also have the crankshaft. The camshaft, as we saw earlier, those are this is the unit that controls the movement of the valve. Okay, so it is connected to the main engine rotation, and you can see these are the lobes on the crankshaft. Okay, that pushes the. We have cam followers on them, as we'll see later, and then in some arrangement we have the push rod. So those push rods, they are the ones that are responsible for the movement of these rocker arms that we saw here previously. Okay, so those are what the push rod they do. So that's the function of the valve, and the function of the camshaft basically is for the valves, okay, to aid the movement of the valve. So this is a coupled engine now, as we have been discussing. So this is the piston, these are the pistons, okay, this is the combustion chamber. So you see that in the power stroke, or when after combustion, the energy that is contained in that combustion product will force this piston to move down. So that high kinetic energy is converted to that movement, okay, on the piston, and the connecting rod will transfer that movement to the crankshaft. This is the crankshaft. So it will transfer that movement to the crankshaft, which will now convert it to rotating mechanical energy that will be available at the flywheel, as you can see here. Okay, so here you see that this camshaft is on top, okay, and we have the cam followers. So as this lobe is pushing down on this, it will push down on this valve to force it to open. Okay, then when the lobe passes is no longer on the cam follower, you see that this spring that has been tensioned or compressed, that has been compressed, will be released, and then it will return the cam follower back to its normal position, and then this valve will close. Okay, so you see that it helps us to open and close the valve when they are needed. When we need to admit air into the combustion chamber, it opens the intake valve, and then the air will be allowed to flow into the combustion chamber. Then after combustion and after the power stroke, during the exhaust stroke, you see that that combustion product will be exhausted. So at that time, we need the discharge valve to open up, so that the exhaust gas, okay, the combustion product, will be exhausted at that stage. So we also have the bottom plate cover, okay, that covers the bottom of a cylinder block. So this is another arrangement that is quite different from what we discussed at that time. You see, this is the push rod that we are talking about, okay, that pushes the rocker arm or activates the movement of the rocker arm that will now push all of these valves. Okay, so you see that it has the tappet or the cam follower. Okay, you see it pushing the rod as it is turning. When the lobe gets to its position, it will push it up. Okay, as it's pushing it up, the rocker arm will be forced up to press the valve on the other side to open. Are we getting it? So that is how it actually functions. So still on the diesel engine components, parts, and operations, we are going to be looking at the fuel system. That is another very important part of the diesel engine, the fuel system. You know, we need fuel, okay, for combustion. That is where we get the primary energy from. Remember, the function of the diesel engine is to convert the chemical energy that is contained in fuel into rotating mechanical energy. So that fuel has to be brought into the combustion chamber or the cylinder for it to be burned, okay, to release the energy that is contained in it. So the fuel system starts from the fuel storage. From the fuel storage, which could be a tank under the engine itself or could be a tank elsewhere. Then from the fuel storage, we have a filtration system, okay, that helps to filter whatever debris that we have in the fuel, and also to remove if we have maybe water, okay. So there could be, if we suspect that the water could be in the tank, though if we allow it to settle in the tank, okay, and we avoid the temptation of taking fuel from the base of the tank. If we take from a particular spot above the base of the tank, of course, we know that if there are water in the fuel, all of them will settle to the ground. So we must have a maintenance strategy in place to always be checking out, because water in the tank is not too good. Okay, we will see that later, especially if that water is transferred into the fuel system of the engine. So after the filter, the main filter, then that fuel will now be sent to the injection pump. So this is the first part of the fuel system in the engine itself, in the machine itself. Okay, we have the filter. From the filter to the injection pump. So the injection pump, its function basically is to pressurize the pump, the fuel that is fed into it, okay, to raise the pressure of the pump to a level that will be high enough to break up the nozzle. You know, the nozzles, they are calibrated to be open at a particular pressure. Are we getting it? So if the pump is unable to raise the pressure of the fuel to that level, it will not be able to open up the nozzle, okay? And it is designed because of the function of the nozzle itself. The function of the nozzle is to atomize the fuel. So if that pressure is not attained, it will be very difficult for the fuel to be atomized, and that will affect the combustion in the cylinder. So after the pump itself, that its function is to raise the pressure, we have the nozzle pipes, okay, and then the nozzle itself. I will get this. Okay, so this is the fuel pump. This is the fuel filter. I mean to say, this is the fuel filter here from your diesel engine, not the one we earlier said. Okay, so from the filter, it will now come to the pump. The pump will pressurize the fuel, and then it will send through these nozzle pipes to the nozzles. Okay, so the function of the nozzle is to atomize the fuel into the cylinder. So that is the fuel system, and its operation is very critical to the overall operations of the diesel engine, and maintaining their optimal performance is also very critical to the efficient operations of the diesel engine. So at all time we want to be sure that the pump is delivering at the right pressure, okay, and then the nozzles, they are under, that is, they are the right calibration level as required by the engine manufacturer. So this is the pump, and you see all of the outlets to the nozzles, okay, and this is the nozzle, and this is the nozzle tip that will directly inject the fuel into the combustion chamber. That is what we have here. So the pipe, this pipe is connected to either the top or side depending on the configuration of the nozzle itself, okay. So this is what is now connected on the cylinder head as we saw earlier, and then this cylinder head is meant to cover the top of the cylinder on the block as we saw earlier. So this is a kind of summary of the fuel system, okay. So here we have the tank. From the tank it goes through the fuel pump, okay. Then we have the manual priming pump, then to the main injection pump also, okay. The main injection pump that is meant to pressurize the fuel to the level that it will be able to break all of these nozzles. Are we getting it? Here we have a common rail like the one we saw earlier. So here you can see that we have a control module, okay. This control module controls the timing of the injection of all of these. And that reminds me, you see that this one is connected, the pump itself is connected to the jar assembly on the engine itself, okay. So it is timed such that it is when we want each of these nozzles to deliver fuel to the cylinder that you will see the pump sending pressurized fuel to that particular nozzle, okay. So all of them, they are not pressurized at the same time. Are we getting it? So but in this case now, what is controlling it is this control module, control the timing of fuel injections from all of these nozzles, okay. And you see that it is also tied to this common rail or common header, okay, that also looks at the pressure at this common header, because if this is not delivering the right pressure, here will not be pressurized to the right level. So we have seen the function of the fuel system is to deliver fuel at the right pressure, okay, to the combustion chamber, to each of these cylinders as at when it is needed in each of these cylinders, okay. So this is a summary of also the fuel system from the pump through the common rail to the nozzles. Are we getting it? So these nozzles, they are connected to each of those cylinders. As you can see here, see the nozzles in the cylinder, okay. So when the piston, as we'll see later, you will see that when this piston has been driven to the top dead center, the fuel will be injected, okay. At that point it will be combusted also, so that will now the force or the energy in the combustion product will force the piston down. So that downward movement, okay, translational movement, will be converted to rotating mechanical motion by the crankshaft, as we said earlier. So this is the arrangement. Okay, we have two valves here. One is the intake and the other is the discharge valve. These are the rocker arms that we discussed earlier. So you see that this spring, as the push rod pushes the rocker arm up, that will depress on this spring, okay, as it is pushing on the valve to open. Are we getting it? So the spring at that point will have been compressed. So when the camshaft lobe has moved away from the follower that pushes that push rod, as we saw earlier, you'll see that the force on the rocker arm will have been relieved. Okay, so once it's relieved, this is compressed already, it will release, and then the valve will return back to its closed position. So that is how, like we said, we have both the exhaust and the intake valves. So all of these components that we have discussed now, when you put them together, we'll have something like this. But we still have other auxiliary components that, as you can see. Okay, so we'll also look at all of these briefly as we go along. So we have seen the fuel system. Now we want to look at the lubrication system. Remember, we said those joiners, since we have metal to metal contact on those joiners, we really need to ensure that they are properly lubricated so as to reduce the friction, okay, at those points on the crankshaft, even on the camshaft, and also on the piston within the cylinder itself. You know, as it's moving up and down, it is scraping on the cylinder wall. Okay, so we actually need to reduce the wear. We need to lubricate that area so as to aid the to and fro movement of the piston. So here we have the lubrication system from the oil sump. Okay, we have a pump that pressurizes the oil through the filter before it is sent into the engine. You remember those hoses that we talked about in the crankshaft? Okay, so it is sent through those hoses to the various joiners within the crankshaft, and then you see it coming on top the valve cover, and as it is flowing down, it lubricates all other moving parts. Okay, that will flow down through to the camshaft and then back into the oil sump. So in summary, what you are seeing now is the lubrication system from the oil sump through the filter into the engine and back to the sump. So the first part is the oil pump. Okay, so the oil pump is usually mechanically driven. It's tied to the crankshaft movement also. So the rotating mechanical energy that is provided or produced by the crankshaft will be available at the gear end, the gear assembly end, and the pump will take the energy from that place to do the work that it needs to do. So that is what you are seeing here. In summary, the lubrication system lifts the oil, okay, send it through to the oil pump, then into the engine. Some will go to the valve cover, okay, top of the valve, that will aid the lubrication of all other moving parts on that side. Then if you look to your left, you will see that the cylinder itself needs to be lubricated. Okay, so on the piston, you know, we have three sets of rings. We have the wear rings, we have the oil rings, and we have the compression ring. So the compression ring basically is to assist us so that during the compression cycle, compression is not lost from the cylinder, while the oil ring is like a scraper ring that helps to scrape the oil down. Okay, then we have the wear rings that we sacrifice for the piston and the cylinder or sleeve in the cylinder itself. So that means preferentially the wear rings we wear compared to the sleeve or the piston itself. Okay, so everything put together, the fuel system, the oil system, this is what we have. And then you know that in the oil system, it's only the oil filter that will be available for us to see externally. Okay, that is the only part that is visible externally in the system. This is the sump that is housed by the bottom plate, as we said earlier. So the next part that we'll be looking at is the cooling system. Okay, the cooling system of the diesel engine. So the combustion takes place within the engine itself, and the combustion product is usually very hot. Okay, so heat is one of the byproducts from the combustion process. Are we getting it? So since heat is one of the byproducts, the engine definitely will heat up. So we need to cool the engine, remove those heat from the engine so as to protect the engine from being destroyed by heat. So in summary, the cooling system is what we see here now. Okay, we have a cooling water pump, which is the first part of the cooling system. This is the cooling water pump. Okay, so then we have a reservoir of water, and then the cooling water pump sucks in that water and sends it into the engine. You see the part circulates around those cylinder, that is around the cylinders, to remove those excessive heat from around the cylinders. So in the block we saw earlier, you saw those holes. We'll see it later again. You saw those holes. Those are the hole for water to go through. Even on the cylinder head itself, there are channels on them through which the water can pass. So, but summarily, this is what it does: send the water pressurized at a particular pressure into the engine to carry off the heat. Okay, then it is sent back into the reservoir. There is always a thermostat here. When the temperature rises to a level, the thermostat will open up, and then the hot water will start flowing into the reservoir. So the reservoir is the radiator. So the radiator is a heat exchanger. Okay, so in the radiator, you see that each of the cells within the radiator, there are water channels to separate those hot water into smaller volumes, so as to increase the surface areas. Okay, then the fan, its work is to force air. Either if it is suction, it will pull the air, as in this case now, pull the air through those fins, radiator fins. Okay, or it can blow air onto the radiator fins, depends on the configuration. But basically, that air that is forced through the fins comes into contact with the fin. So the heat that has been transferred by conduction onto those fins, they are what? They are extracted by that air, also through conduction, and taken off into the atmosphere or wherever you want to send the hot air to. Okay, so the radiator, basically its function is to do the work of exchanging that hot the heat, okay, to the atmosphere. That is cooling the water, the hot water that is coming from, or the cooling water that is coming from inside the engine. Okay, so the cooler one will now be sent into the engine itself. So you see that the efficiency of this operation, okay, will be affected by the rate of heat exchange around the radiator itself. and the rate at which the pump is sending water, the flow rate, into the cylinders, into the engine. So if those rates they are affected, definitely it will affect the efficiency of the cooling system, the efficiency of the engine itself, okay, and may affect the overall output, causing overheating within the engine. So the cooling system is a very important system in the engine itself. So this is the block, okay. So you see the hose that we are talking about the other time, okay. All of those hoses, they are for cooling water. Are we getting it? They are for cooling water to run through to cool the engine. So as the engine is cooled, okay, the water is heated up and then sent to the radiator for the heat to be exchanged to the atmosphere. Are we getting it? So that's the cooling system. So this is the water pump. It's a centrifugal pump. It's always attached to this end. So this is the fan. Okay. So you see that anything that affects this fan will affect the rate at which heat is transferred to the atmosphere also. Are we getting it? Then we have the radiator. Okay, the fan is always at the back of the water pump. You see where it's attached to. This is where the fan is attached to. Okay, it's connected to the front of the engine. Are we getting it? So the pulley. This pulley, we have a drive bed that connects to the main shaft, the main jar on this crankshaft, okay, that helps to drive the water pump. Are we getting it? So this is the complete engine having every other thing that we have said. Okay, so putting it all together, this is the major that is the part that houses every other component that we said earlier, which is the engine block. Okay, so we have the cylinder cover. Between it, we have the top gasket, or the top cylinder gasket is usually a fire gasket because we have fire. The heat temperature here is usually very high. Okay, then here we have the valve cover. Then we have the valve cover gasket, as you can see here. Then this is the bottom plate or oil pan. Then this is the bottom plate gasket. Okay, then we have the induction manifold and the induction gasket or intake manifold gasket. Then we have the exhaust manifold here, okay, that is attached to this end of the top gasket or cylinder, top cylinder or cylinder head. Then this part is attached to this end. Are we getting it? Then we also have the fire gasket or exhaust manifold gasket. Since the temperature we expect here to be very high, so it has to be a gasket that will be able to withstand that high temperature. So once you have all of this coupled together, this is what we have. We now have the complete mechanical part of our diesel engine. So next we'll be looking at the combustion process. What actually happens within a diesel engine. Like we said earlier, the diesel engine is an internal combustion engine, a reciprocating engine, a 4-stroke engine. Are we getting it? And these are the 4 strokes that you are seeing here now. Okay, so we have the intake stroke. In the intake stroke, you see that the piston is moving down. As the piston is moving down, it kind of increases the volume within the chamber, okay, and that reduces the pressure, creates a kind of vacuum. So that reduced pressure will cause this valve to push down since the pressure here is higher, is expected. Although the rocker arm movement is what, as we explained earlier, causes this movement of the piston, the valve. So the valve will open, the rocker arm, you see it's depressed. The rocker arm will push the valve to open, the intake valve. So since the pressure outside is higher, air will flow into the chamber. Okay, so that is the intake stroke. Then once the piston has been driven to the bottom dead center, when the crankshaft, that particular lobe is that particular journal is returning up, you see that the piston will start driving up. At that time, this valve will have closed. Okay, this valve will have closed. That is, the intake valve will have closed. And then as the piston is moving up, it's reducing the effective volume of the cylinder, and that will end up compressing the air that has been admitted into that cylinder. So it will compress it, okay, to the top dead center where the pressure on the compressed air is highest. Then at that instance, the injector nozzle, the fuel nozzle, will inject diesel fuel into the chamber. Okay, remember that compression force on the air has already heated up the air already, in addition to the fact that maybe this event may be happening when the engine is already hot. Okay, so as the fuel is injected into that compressed air, you see that that air fuel mixture will now ignite. That is what we are seeing here. Okay, and so the will now combust, ignite or combust. That combustion product has very high energy. Are we getting it? So that high energy is what will now push on the piston, down. Okay, so you see that that energy will now be converted by the piston to that motion downward, that translational movement downward, or straight line movement downward. Are you getting it? So that motion will be transferred to the connecting rod, which will then eventually transfer to the crankshaft that will now turn it into rotating mechanical motion. So this is the power stroke, since it is actually the stroke that pushes on the piston itself to drive the piston downward. Okay, then as we go past the power stroke, as the piston is returning, the exhaust valve will open up. Again, that movement is controlled by the camshaft, rocker arm, and the camshaft rocker arm combination. So it is open up, and then the hot gas will now be pushed through the exhaust to come out. So that is now the exhaust stroke. So the diesel engine is also a 4-stroke reciprocating engine, as we said earlier. Okay, so this is the cylinder. This is a 4-cylinder engine, as you can see here. These are the nozzles, as we saw the other time. These are the valves, okay, the valve spring, the rocker arms. Are we getting it? The follower, okay, the car header is the push rod, I mean to say. They are there. Okay, so what we have just explained is what we are seeing here now. So this is exactly what we explained earlier. Okay, intake, this is intake, compression, ignited, power, then exhaust. Are we getting it? So that is exactly what is happening within the internal combustion engine, as we said before. So that is what we are seeing now. You see the crankshaft converting the to and fro movement of each of these piston and connecting rod combination into rotating mechanical motion. Okay, so this rotating mechanical motion is what we now have available for driving our load. So you see some of the energy is used to drive. This is the water pump that we discussed the other time. Okay, drive into the engine. Then the hot water goes back through the thermostat into the radiator. Then the radiator cools it by this fan blowing air into its conduction, convection, and radiation. The water is cooled and then sent back into the engine through the water pump. So we have seen the combustion process now in the diesel engine. So basically, here we are going to look at the two types. We have the inline engine, that is the straight engine, and the V engine, as you are seeing here. Okay, so the straight engine, the piston, as we saw earlier, they are in line. They are in one line, as you can see in this case too. They are in a straight line. Okay, so that is the inline engine. Then the V engine, the piston is arranged, the configuration is like a V shape, as you can see here. Okay, that is why it is called. Okay, so the function is the same thing. Convert the energy that is contained in the combustion product into the translational motion. Okay, that is transferred by the connecting rod to the crankshaft, which will now convert it into rotating mechanical motion. So this is the V engine, and that is the inline engine. That's the much we will take on that.